Imagine a world unlike any we know. A world bathed in sunlight yet strangely, eerily silent. The vibrant chorus of birdsong has faded. The busy hum of insects is no more. Even the rustle of leaves in the wind seems muted, hesitant. This is Earth, but not as we cherish it. It is an Earth struggling for breath. The air, once a life-giving ocean around us, has become thin. It is a shallow pool, no longer deep enough to sustain the myriad lives that depend upon it. This is a chilling glimpse into a possible future. A future where the very essence of life, oxygen, becomes a scarce, precious commodity. The change was not sudden, not an overnight catastrophe. It was a slow, creeping decline. Generations might have passed, noticing little. Perhaps the mountains seemed harder to climb. Perhaps the old grew weary more quickly. Subtle signs, easily dismissed. But beneath these gentle warnings, a profound shift was occurring. The planet's delicate balance, the intricate dance of elements that produces our breathable air, was faltering. The great atmospheric engine which has powered life for eons was sputtering. The air, our constant companion, our unnoticed sustainer, was slowly, inexorably failing. This scenario, though stark, serves as a profound reminder. It reminds us of the fragility of our world. Where does this vital air, this oxygen, come from? It is not simply here by chance. It is the product of life itself. Tiny organisms, often invisible to the naked eye, are the true heroes of this story. In the vast oceans, microscopic plants called phytoplankton float near the sunlit surface. They are incredibly small, yet their numbers are astronomical. Like plants on land, they perform a miraculous process. They breathe in carbon dioxide, our waste gas. They use sunlight for energy, and as a wonderful gift, they release oxygen. These tiny beings are responsible for producing at least half of all the oxygen we breathe. On land, the green world continues this vital work. Every leaf on every tree, every blade of grass, every humble shrub is a small factory. These plants too capture the sun's energy. They draw water from the soil and carbon dioxide from the air. Through the magic of photosynthesis, they create their own food. And in doing so, they release the oxygen that sustains so much of life on Earth. Forests, grasslands, even the smallest garden, all contribute to this global life support system. The Amazon rainforest, often called the lungs of the planet, is a vast and powerful oxygen producer. Its dense vegetation works tirelessly, day after day. This process, photosynthesis, is truly one of nature's greatest inventions. Our Earth was not always an oxygen-rich haven. For the first 2 billion years of its existence, the atmosphere was very different. It was a world of methane, ammonia, and carbon dioxide. A world where life, if it existed, was simple, microscopic, and hidden from view. There was virtually no free oxygen to breathe. Complex animals, as we know them, could not have survived in such an environment. It was a truly alien planet compared to the vibrant blue marble we inhabit today. This early Earth was a stage waiting for a dramatic transformation, a revolution in its atmospheric chemistry. Then, something extraordinary happened. Around 2.4 billion years ago, a new kind of life emerged. Tiny organisms called cyanobacteria evolved a remarkable new skill. They learned to harness the power of sunlight in a new way. They began to perform photosynthesis, and as a byproduct of this revolutionary process, they started to release oxygen. At first, this oxygen did not build up in the atmosphere. It reacted with iron and other minerals in the oceans and on land. Great bands of iron formations found in ancient rocks tell this story. They are the rusty evidence of oxygen's first appearance. This period is known as the Great Oxygenation Event. It was not a sudden event, but a gradual transformation that unfolded over millions of years. As these tiny cyanobacteria continued to pump out oxygen, they slowly changed the world. For hundreds of millions of years, Earth's oxygen levels have remained relatively stable. They have fluctuated, certainly, but have stayed within a range that supports complex life. This stability is a result of a delicate balance. The balance between oxygen production by plants and phytoplankton, and oxygen consumption by animals, by decomposition, and by geological processes. However, scientists are now looking far into the future. They are using complex models to understand how our planet might change over vast timescales, and some of these predictions are sobering. They suggest that Earth's oxygen-rich era may not last forever. One primary driver of this long-term change is our sun. The sun, like all stars, is gradually getting brighter. As it brightens, it warms the Earth. Over hundreds of millions or even a billion years, this increasing solar radiation will have profound effects. It will accelerate the weathering of rocks on Earth's surface. This weathering process consumes carbon dioxide from the atmosphere. As carbon dioxide levels fall, it becomes harder for photosynthetic organisms, our vital oxygen producers, to survive. Plants and phytoplankton will struggle to capture enough carbon dioxide to make their food. Section 5. Life's last gasp, an Earth without sufficient oxygen. Imagine this distant future, an Earth where oxygen levels have plummeted. What would become of life as we know it? The consequences would be catastrophic. For animals like us who depend on a constant supply of oxygen, survival would become impossible. Our lungs are designed to extract oxygen from air that is about 21% oxygen. If that percentage drops significantly, we simply cannot get enough. Even a drop to 15% would cause severe problems. Breathing would become labored. Physical activity would be severely limited. Consciousness itself would be threatened. The first to suffer would be the large, active animals. Creatures with high metabolisms, like mammals and birds, require a lot of oxygen to fuel their bodies. They would be the canaries in this planetary coal mine. As oxygen thins, they would struggle, then disappear. Smaller, less active animals might hold on for longer. Insects, with their different respiratory systems, might fare better initially, but eventually, they too would succumb to the suffocating conditions. The vibrant tapestry of animal life woven over millions of years would unravel thread by thread. Section 6. Local suffocation, the human hand in oxygen loss. While the catastrophic, planet-wide deoxygenation event lies in the very distant future, human activities today are already causing localized oxygen declines. These are particularly evident in our planet's precious water bodies. Rivers, lakes, and coastal areas are suffering from a phenomenon known as hypoxia, or low oxygen, and anoxia, which means no oxygen at all. This is not a depletion of the air we breathe directly from the atmosphere on a large scale, but it is a critical issue for aquatic life and the health of these ecosystems. These are often called dead zones. The primary culprit behind these aquatic dead zones is nutrient pollution. When fertilizers from farms, sewage from cities, and industrial discharges flow into waterways, they carry excessive amounts of nutrients like nitrogen and phosphorus. These nutrients act like a super fertilizer for algae. This leads to massive algal blooms, sometimes vast enough to be seen from space. While algae produce oxygen during the day through photosynthesis, a problem arises when these massive blooms die and sink to the bottom. Their decomposition by bacteria consumes huge amounts of dissolved oxygen from the water. This bacterial consumption of oxygen can be so intense that it strips the water of nearly all its life-giving air. Fish, crabs, oysters, and other aquatic creatures that cannot escape these low oxygen zones effectively suffocate. They die in large numbers, leading to a devastating loss of biodiversity and damaging fisheries that many communities rely upon. Section 7. Breathing easy. Our role in protecting the air. While we cannot stop the sun from aging or alter the deep geological cycles of our planet, we can certainly take action to protect and preserve the Earth's oxygen cycle from human-induced harm, especially in our local environments. The fight against aquatic dead zones, for instance, is a battle we can win. It begins with managing nutrients more wisely. Farmers can adopt practices that reduce fertilizer runoff, such as precision agriculture, planting cover crops, and creating buffer strips of vegetation along waterways. These simple measures can significantly cut down the amount of nitrogen and phosphorus entering our rivers and seas. Improving wastewater treatment is another crucial step. Cities and industries must invest in modern treatment facilities that can effectively remove nutrients before wastewater is discharged. This prevents the overloading of aquatic ecosystems and helps to starve the algal blooms that lead to oxygen depletion. Protecting and restoring wetlands is also vital. Wetlands act as natural filters, trapping sediments and absorbing excess nutrients. Their conservation and restoration provide a powerful, nature-based solution to improving water quality and safeguarding dissolved oxygen levels for aquatic life. Every restored wetland is a step towards healthier waters. On a broader scale, protecting our forests and reforesting degraded lands are essential actions. Trees are not only crucial for producing atmospheric oxygen, but they also play a key role in the water cycle and in preventing soil erosion, which can carry nutrients into waterways. Section 8, a future filled with air, the hope we carry. The thought of an Earth without breathable air is indeed a sobering one. It paints a picture of a desolate future, a stark contrast to the vibrant, living world we know and depend upon. The long-term astronomical scale deoxygenation is a destiny tied to the life cycle of our sun and the geological evolution of our planet, far beyond our influence. However, the more immediate threats, the localized oxygen declines in our waters, are a different matter. These are challenges born of human activity, and therefore they are challenges we have the power to address. This is where our hope truly lies. The Earth's systems are remarkably resilient. Life has an incredible capacity to recover, if given a chance. When we reduce pollution, when we restore habitats, when we manage our resources sustainably, ecosystems can bounce back. We have seen rivers cleaned, forests regrown, and species return from the brink. These successes, though sometimes small in scale, demonstrate that positive change is possible. They show that our actions, guided by understanding and a sense of responsibility, can make a profound difference. The future of our planet's health is not predetermined, it is shaped by the choices we make today. The story of oxygen on Earth is a story of transformation, of life's power to shape its environment. From the ancient cyanobacteria that first gifted us our breathable air, to the vast forests and oceans that maintain it today, it is a legacy of interconnectedness. We are part of this grand living system. Our well-being is inextricably linked to the health of the planet. By recognizing this, by acting as stewards rather than mere consumers, we can help to maintain the delicate balances that make Earth habitable. We can ensure that future generations inherit a world that is still full of life, still breathing easily,